5 is about integrals, antiderivatives, and areas. Okay, girls? And section 5.1 is about estimating the area under the curve using rectangles. That's all it is. It's called a Riemann sum. And on your calculator, it has two ends, just like this. And you can run the program. It's very nice. It draws in the rectangles. It uses all the midpoint rules or trapezoid rules, whatever you'd like. Now, the problem is on the exam, this will be in the non-calculator section. So you will not bail out a calculator. So you have to be able to do it by hand. And all I did here in my class opener was use this graph, find the area under the curve, using 4 rectangles. Okay, and this is x squared plus 1. Now, this was done off an older Inspire, which didn't do pretty print. Okay, so I'm going to divide it into 4 rectangles. So I'm going to draw here. And I like to do halves. And what's nice about the Inspire is it does actually divide it up. It shows you the graph more accurately than an 83 or 84. Okay. And what am I going to do? I want rectangles using the height as the left endpoints. We called that LM last year. So here it is. And you probably will have a question like this on the exam. Maybe it'll be just a multiple choice because there's only so many things that you guys can do. Because I have to test the BC topics, and I looked through the old exams. I don't see a lot of this on there, but it could also be easily a multiple choice question. And so then, and I gave you the table. If they give you a table of values, you must use the table. You may not just try to read off the graph. Okay, so all we have to do is find the area of all the rectangles. So the first one is, what's the base? How big is the base? 1/2. I made them all the same for convenience sake. So it's going to be base times height. The height here is going to be f of 0 plus 1/2 f of, I'm hitting on the left side, so it's 1/2. I'm going to read it right out of the table. Plus 1/2 f of, well, that's 1, plus 1/2, and then it's f of, whoops, this one, which is 1.5.
That's it.
And I don't use the other one. Okay? I don't use the right endpoint because I'm doing left. And I could factor out a 1/2. You don't have to. I'm just going to. And if this is non-calculator, it's still not a big deal because guess what? You don't have to add this up. You just have to write it up as addition. That's it. So f of 0 is 1 plus f of 1/2 is 1.25. F of 1 is 2. And f of 1.5 is 3.25. And you may leave your answer that way. That's it. If you want to add, you certainly may. Because you could check it with FNINT on your calculator. Remember how to do that. Remember find the integrals on your calculator? Yeah, it probably would hurt. Well, let's add this up then, since I want to check it. So it's 1/2. And what I do is I add the easy things first. 1 and 2 is 3. 1.25 and 3.25 is 4.5, right? So I have 1/2 of 7.5. How big is that? Okay. So let's see how this works. Now we only did 4 rectangles, so we did x squared plus 1. So you want me to bring it up? I'll bring up the 83. I wish I had, or the 84. I wish I could get my old programs. They were on the computer and then they got taken off. So my backups are gone. Because you're missing a test.
I told you this morning.
I know, I got to grade it.
We graded it.
Yes, I'll grade it in class. I've been trying to get to it all day, just haven't. Okay.
I think I went off on it.
Okay. Now, I'm in pretty print. So we're going to press math. Oh, first I'm going to put my function in. I put it into y equals. So I'm going to clear that out, and it was 1/2. And it was, no, it wasn't 1/2. It was x squared plus 1, wasn't it? Just x squared plus 1? Okay. And I don't know how to get it back to the old way, but anyway. And we could graph it. We could do this. Now, I don't have the right window. So I want to go from what, 0 to 2? So I'm going to do window 0, and I'm going to go to 2. And 2 squared plus 1 is going to be 5. So I don't really have much negative, so let's make that negative 1. I don't have anything negative. And let's make this 6. I think I did my arithmetic right. And there it is. Now when you use Riemann, you don't have to put it into y equals. But we're going to do what all of our calculators do. Second, calculate. And this integral sign means find the area of all the rectangles. That's 7. And we're going to start at 0, and we're going to go to, whoops, press enter. And then we're going to go to 2. And that will give me the exact answer and shades everything in. Your Riemann program will shade in just 4 rectangles, so we can check with my arithmetic. So it's 4.66667, which is 4 and, what fraction is that? 4 and 2/3. Underestimate or over? Under. Now the question is, what determines if it's an underestimate or overestimate?
Concavity.
That's not the concavity.
Oh, it's, what side? It's increasing and decreasing, right?
It's increasing or decreasing. I take a function like this, and I hit the left rectangles on the left side, it's still under, isn't it? What determines if it's over or under is the increasing or decreasing. So this function is increasing. I want to make sure that that's clear, because we did that in AB and it was not clear to the students. I forgot to summarize that for them. Okay, and then it says repeat the process using right endpoints and then midpoints. Use your Riemann sum program. I don't want to spend time on this. It's not terribly hard. Okay, that was 5-1. And so you're going to use your program if you have it. If you don't, you can borrow my calculators. Oh, and I do have to go. I'm not done. There's another page here. What if you divided the region into n rectangles? What would the area be? Well, this gets us into 5-2. So let's go ahead and do this here. And we're going to do what is going to happen on the exam. You're not going to have to do the formal Riemann sum, which is an infinite number of rectangles. So here's my curve. I'm going to exaggerate it so I have plenty of room to write. And you know what? I'm going to start and say this is A and this is B. A in my case is equal to 0. And I'm going to divide it into n rectangles. How wide is each base? I want each one to be the same.
Yeah.
But how wide is it? I'm just going to write etc. because there's going to be a whole bunch.
Yeah.
Etc. No. If my length is from A to B and I divide it into each rectangle, what is delta x? Okay, this is what we have to get, you guys. This is the 5-2, and then the rest of 5-2 will go easily. So if this was 0 to 2, and if I did 4 rectangles, it was 2 minus 0 divided by 4. They were a width of 1/2, right? So how would you find the width here? B minus A divided by how many rectangles you have. That makes sense? And then we want to add them all up. And I'm going to do the right endpoint on these, just because that's what we choose to do, because of our formulas that you don't really know about. This is x sub 0, this is x sub 1, this is x sub 2, x sub 3, and a whole bunch of them. We'll call that x sub I, because there should be something in between there, because we're going to put an infinite number of rectangles in there. We don't do this formally in this class or in the AB class. However, they're going to give you a limit with a Riemann sum in it, and you have to recognize what it is as an integral. That's why we're going to do this right now. So this is delta x, right? And we made all the bases the same. And we're going to hit our rectangles on the right side. So I'm going to draw my rectangles here. So the next one's going to be here. Whoops. Here. You can do whatever you want with a Riemann sum. I'm going to choose this because I have these little formulas like this. The summation I equals 1 to n is equal to n minus 1 over 2. And even it's been a while since I've done this, so I've forgotten all my formulas. And you'll see where I'm going to get this I. Where is that going to come from? But they're all hitting on the right side. So let's look at that. This is not easy. Okay. So how do you find the area of this first rectangle? It's delta x times the height evaluated at x1. Is everybody okay with that? Well, wherever that is. That's f of x1. Is that okay? Plus, and then I'm going to have delta x, and then I want this height, f of x2. Okay, Nicole, which one away? Plus, this is the part that's going to blow you away in a second, f of x3. Plus, I'm going to have an infinite, or n rectangles, I'm going to make it infinite. And so one of the ones in the middle there, I'm going to call that x sub I. So it's still delta x, f of x sub I, and there's still an infinite number of rectangles after that, and I'm going to end up with delta x times this, which is x sub n. I don't want to make it b yet. Well, it is, but I don't want to see the patterns. Delta x f of x sub n. And we've had sigma notation, so we aren't going to be too bad a shape. I hope. What can you factor out of here? Delta x. And I'm left with f of x sub 1 plus f of x sub 2, which is kind of nice that we do chapter 8 first, because that makes this so much easier, plus f of x sub I plus f of x sub n. Now I want to write that in sigma. You guys do that? So first I have delta x, and I could put that inside the sigma, it doesn't really matter. Summation. My counter is I. Where am I going to start? 1. And I'm going to go up to n, and then this is f of x sub I. Is that okay? And if I put this inside, because I'd like to do that, this is summation I equals 1 to n, and that's f of x sub I delta x. And guess what I'm going to do? I want n to do what? Go to infinity, because if I let n go to infinity, I'll color in the entire area under that curve. It's going to go to infinity, and it's the number of rectangles, not where it is. You're going to find this challenging when you're given the summations trying to get it back into what an integral is. And Riemann said, well, you know what? I don't want to write all that every time. So what I'm going to do is I'm going to make up a symbol that looks like an S. In German, the word for sum is this. So my guess is that he probably did say, okay, I'm summing, why don't I just use an S? Because that's the German word for sum. And we're going to add up all the areas. This is f of x, that's my height, and delta x is my dx, and I want to find the area from A to B. And this is a definition. You will remember from last year the fundamental theorem of calculus and how to find that area using antiderivatives. But it should bother you. Why is it an antiderivative? You shouldn't blindly accept things. Well, we will, when we get there, I can prove it to you, because we're going to actually do a little bit more with this. But even more, what Riemann said, this is the most important, the critical part about this, is I don't have to have all these bases the same size. They can be all different sizes. The only condition is that my delta x of the biggest one, that goes to 0. If the biggest base goes to 0, what about all the other ones smaller? They got to go to 0. I can't just have an infinite number of rectangles, because if the base of the biggest one doesn't go to 0, I can put an infinite number of rectangles right in here. I still have not found the exact area under the curve. The deal is you have to divide it up so that all the bases are going to 0. So I make the biggest one go to 0. And then not only that, I don't have to use my sample point to find my rectangle at any of the endpoints or midpoint. I can choose any point. So I could take a sample point like right here and use this to estimate the area of this rectangle. It doesn't matter. So at the University of Minnesota, we had a problem where they had to ensure that the area was under the curve, and it looked kind of like this. Well, if I want to make sure that it's always under the curve on this side, I use the right endpoint. But over here, I had to use the left endpoint. Then I knew for a fact that this area was always going to be less than the actual area. That's what and that's what they try to test with that question, was for you to realize I can mix and match. My rectangles don't all have to be the same. Yeah, it doesn't matter. He's the name of the guy. So they're going to ask you a Riemann sum, but of course you're going to have a finite number of rectangles unless they actually go in and they give you this antiderivative. You have to limit, and you have to write the antiderivative. And then you know how to do it the easy way. Well, what is this x sub I, and what is this delta x? Let's write this up so that we can actually look and see what this might look like. So it's the limit as n goes to infinity. And I know it's a pain to write this. And by the way, on my listserv, there was discussion about those improper integrals. Do you have to write it correctly with the limit notation? Yes, you do. There were readers who had graded those things in the past that responded and said, yes, they did not get the points. They just made it from 2 to infinity, and then you just plugged in infinity. You had to use the limit. When we get to improper integrals, which we will do that again, I'll show you what I mean. I'll refresh your memory. So what was delta x? It was b minus a over n, right? Okay, so that looks weird. That doesn't look like a delta x anymore. I see base and height here easily. X sub I is the tricky one. Okay, we're going to go back up to my picture and figure out what x sub I is. What's x sub 1? X sub 1 is one of these delta x's. Because we started at the origin. But what if we didn't start at the origin? What if our graph did this? What if we started here at A and then we went over a delta x here? Where would my x coordinate be? No? I want to find where I am here on the x-axis. I have to go a distance, right? And then I have to add in my delta x. Does that make sense? So this is plus a. What's x sub 2? How many delta x's am I going to have to go over? 2 delta x. So we didn't start at 0, we started at a. That's what makes this really hard. X sub 3 is equal to 3 delta x. Yes, we're going to do all the delta x's the same, because it's easier. Okay, what if I want to do the I x coordinate? How many delta x's? It's I delta x plus a. I'm going to take this and substitute it into my f of x sub I for x sub I. So it's going to be really weird looking. No, we have to do 5-2, which is, this is the bulk of 5-2. Then after that it goes very fast and easy. I'm not done. So this is f of a plus I delta x, or I times b minus a over n. It's starting to look less and less like an x coordinate, but that is the x coordinate, times b minus a over n. And then what our function we had before was x squared plus 1, and a was equal to 0, b was equal to 2, and we'll leave it as n. So let's just get this set up, and then we'll do the 5-2s, and then we'll be done. It's the limit as n goes to infinity. I know it's painful to write that. Okay, so it's x squared plus 1. So I'm going to substitute this in. It's going to be f of a was 0, so it's plus I times, what's b minus a? 2. So it's 2 divided by n. And this is 2 over n. Okay, one more step. We're going to substitute that into our function. And this is what you have to realize. They could give this to you, and they like to even make it harder than this. And so this would be x squared, so it's 2i over n. That's my x squared plus 1 times 2 over n. And I'll try and find those multiple choice questions that are like this. Some are without limits, because you could do n equal to 50, for instance. Now, that doesn't look like a function to me. I don't see any x's in there, but I see it now, but I'm sure that you probably are looking at it saying, that's not x. This is my x, that's x sub I, and this is my delta x. And so what you would do is be given this and say, oh, that's the antiderivative of, that's x squared plus 1. This is my dx. That's the easy part. And then the hard part is I have to figure out what a is. But I know what a is. I know that this is b minus a. Because there was nothing added onto that x, there's no plus anything, we have to start at 0 then. It would say plus 1 if you were starting at 1 on the x's. And then you go, since b minus a is 2, then this has to be 2. And then you can do that problem. Mm-hmm. And that's hard. This is not easy stuff. More? They were up here. And it's all geometry. Taking the limit is what's hard. And then how do you do the algebra to simplify that if you want to do it the way Leibniz and Newton and Riemann did it before they finally figured out it was an antiderivative? The algebra is hard. Okay. Yeah. And so that, when you look at 5.2, on the first side is what I did, and I knew I didn't have enough space, so I decided to do it here.
Where your sweatshirt for? Is this for the section?
This is 5, it really is the 5.2. That's what I did on the very first part of 5.2, I did that here. I just knew I didn't, when I looked at it, I don't have enough space. Oh, this isn't supposed to be written up here. Oh. I'll leave that. Okay. Oh, that's a much better picture than what I had. Okay. So I will refer you back on 5.2. Go back to, when you do this part, go back to what we just did. So I'll say C 5.1 notes.
Wait, do we have to,
You're not going to have to do a formal Riemann sum like I just did. You're going to have to recognize it. Let's do the examples. Then you'll see.
So what you did was part of 5.2
Right. That actually was 5.2. We actually made you, when I drew the picture and I divided it into n rectangles, etc. Okay, that was 5. I did it in 5.1 because I knew I didn't have enough space.
we have to do a stupid trapezoid one?
Trapezoid rule, yes, we'll be doing that. Oh, we almost always have that. Okay, now let's go down further and let's do this one. Now, this is out of the old book, so I don't know what problem it is, and you changed the problem, so I don't even know if it's in your homework. All I have to do is write this as a Riemann sum. Oh, I couldn't say it's that easy, though. Well, it's number 6 out of the old book. It's on your sheet. So I want to write it this way. It's the limit as n goes to infinity, summation I equals 1 to n of f of x sub I delta x. So what's delta x here? It's 3 minus 1 divided by n rectangles, so it's 2 over n. Right? So this is going to give me, and I'm trying to think if they want anything fancier than this. It's 1 over, whoops, I forgot my summation. I equals 1 to n. 1 over 2 times x sub I minus 7 times delta x, and delta x is 2 over n. That's all they're asking you to do. We're almost done. No, we have more than that. 25 minutes. Okay. Now can you guys tell me what x sub I would look like?
What?
X sub I. What is that? Well, define, it looks like this kind of graph. But now I'm starting at 1. So here's my first x coordinate. So x1, I have to get over to 1 first and then add in one of those. So 1 delta x. Do you see that?
Yes, because you start at 1.
If I go x2 is 1 plus 2 delta x. So what's x sub I? 1 plus I delta x, which would be 1 plus I times 2 over n. And I could put that in here, or at least label it. The problem is, they're going to give you this limit, and you've got to get back to this. That's the problem. Well, I'll find them. I've usually seen, it's only one problem. I usually have seen one almost every single year that I can see this. Now, all they're asking for you to do is write this integral. And I have to erase this because it's in the middle of my tool. So what is that integral?
From 0 to 2 pi.
0 to 2 pi. What's my function?
It's the x squared minus half.
So this is easy.
And then dx.
Much easier. But they're not going to give you easy things on the test. It's all they're asking you to do when they say, write the following Riemann sum as a definite integral.
Wait, Miss G, for the one right above that, do we have to break that what we just found in there? Or can we do that as
What they're going to do is they're going to give you something like this on the exam, but you're going to have to recognize it. And I have to do this 1 plus I delta x for you to recognize it. You'll see. I'll find the problems and I'll give them to you.
You're saying you have to put that 1 plus I times 2 into the x pi?
No, they're not going to ask you to do that in the exam. It's going to be the reverse. You're going to be given this, and you're going to have to figure out what the integral is. This is easy, what they've done for you. Way easier than what you can see on the exam. There's some homework problems I have you do it. Make sure you do it, and we'll do it. We're almost done.
Are you still collecting homework, or can we just do homework I do?
We're doing homework if your grade drops below 90%.
Below 90%?
Are you serious?
There are some people that have to turn in homework. Uh-oh.
Oh, yes!
Hi. Different song?
Dennis really complimented your voice when you left.
So you recorded this still?
Sure.
You want it?
Sunshine on a cloudy day. When it's cold outside, I got the month of May. I guess you would say, what can make me feel this way? My girl, my girl, my girl, talking about my girl, my girl. I've got so much honey, the bees envy me. I've got a sweeter song than the birds in the trees. I guess you would say, what can make me feel this way? My girl, my girl, my girl, talking about my girl, my girl. I don't need no money, fortune or fame. I got all the riches, baby, one person can claim. Well, I guess you'd say, what can make me feel this way? Nicole, 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 talking about Nicole, Nicole, Nicole.
Okay. Now, going on. Okay, guys? What is it? What is an integral, by the way? What is an integral? It's a signed area under the curve. So it's like displacement. And actually it does. It represents the displacement. What's the difference between displacement and distance? I'm going to walk over here, Nicole, and I'm going to go back. My displacement is 0, but my distance is not 0. So you have to use absolute value. So
Oh, this is one thing, like, underneath, it's still under the curve.
we're just going to use geometry.
I don't want to use geometry.
We're not, oh yeah, so when you see a picture like that, you're going to go, yes, geometry. Can they what? If you look at what we pulled out for AB, every single one had geometry in them.
But I mean, like, I like this grid coordinate
That's, it's kind of nice. And they sometimes do, sometimes they don't. So I want the area from 0 to 2. Can we just count?
Yeah.
1, 2, 3, 4. Good enough. How about 0 to 5? So it's 4 plus, and I want to go to 5. Oh, should we do this one? Plus 3 squares, and then how many, what do you got here now? We've got, that's 3 to 5, right? So it's plus 1/2, the base is 2, and the height is 3. So it's 7 plus 3 is 10. What's the next one say? How about 5 to 7? So it's going to be -1, because the y value is negative, that's why. 5 to 7, that's a base of 2, and a height of really -3, but I put my negative there. So that's just -3. And what about 0 to 9? I'm going to add up everything I have, which is 10 minus 3, and then I have to go from 7 to 9. Oh, that's a trapezoid. Do you remember that formula?
1/2 base times height divided by.
You have to add the two bases. Okay, this is 7, that's 9, so the height, this is the height, is 2, and then it's this base, which is 3, plus 2, and what's wrong with this? I still made a little mistake. No, I got it right there. It's negative because it's underneath the axis. So it's 7 minus 5, so it's 2. Another thing to do would be just to match up triangles that have equal areas, if you can. And they do set them up like that on the exam. So if you get problems like, and it's 23 in the old book, I don't know what it is in the new book. Let's move this guy over here. And we're just going to do this as areas. We are not taking antiderivatives. So let's graph this. Okay, what does this look like, this line? It's a line with a y-intercept of 1. Looks like that. And we're going to go from 1, 2, 3. Are you okay just using a trapezoid? You could break it into rectangles. Now, last year when they were asked to do trapezoidal rule, the students who did break into rectangles and triangles were given full credit, provided it came out to be the same answer. But we have a new chief grader this year. So they might say, no, if it asks for trapezoidal rule, we want to see trapezoidal rule, which would make it a lot easier to correct. I didn't correct that one, but that's okay. So let's see, it's 1/2 the height, which is 2, times the sum of the bases. So I have to find this out. What is f of 1? This is f of 1 plus f of 3. So just substitute that in there. 1 plus 2 is 3. And what's f of 3? 1 plus 6. So it's 1/2 times 2, and that's 3 plus 7, and the 2's go, which gives you an area of 10. What about the next one? I think that's my last one, actually. Yeah, it is. Almost. What about the next one? Anybody recognize that? Justin, do you recognize that? It's a circle because y equals this, and we'll square both sides. So y squared equals 9 minus x squared. If I add x squared to both sides, I get x squared plus y squared is 9. The radius is 3. I'm going to draw a picture just to make sure, because the circle itself is not a function. What part of the circle is this? It's the top half. So what part of a circle do we have? What part of a circle do we have? Justin?
Semicircle.
It's 1/2 pi, and the radius is 3 squared. Okay?
I don't know.
The middle of the circle, I mean the center.
Obviously.
And so you're going to use geometry. You're not going to find antiderivatives. So be careful. Sometimes you know too much.
Look later. Want to hook a brother up?
You want a jersey?
I do.
You are getting one.
And then on Tuesday, you will have time to work on 5-1 and 5-2 in class. We go on to 5-3 on Wednesday. And I think that's a 2-day deal. Okay, ready, girls? Write that as a single integral. There are properties of integrals. If you have the area from A to B, and then take the area from B to C, can I write that as a single integral? That's A to C. Also, here's another property. If I have the integral from A to B, how does that relate to the integral from B to A? It's negative. So this is 3 to 8 and then 3 to 5. So sometimes it helps me at least to draw a picture. I don't know what f of x looks like. I don't really care. Okay.
What? It's beautiful.
There's 3. There's 8. So I have this area, and I'm going to subtract off from 3 to 5. What's the answer going to be then?
8 minus integral of 5 to 8.
5 to 8. So this isn't too bad, but do the end problem because they give you a Riemann sum at the end. Now, the page numbers are not going to be right. Make sure you look up your properties. Make sure you know what your midpoint rule is. And those page numbers are all wrong. Okay?